Let's take a look at multiplying numbers that are in scientific notation. Specifically, we're going to multiply 3.64 times 10 to the negative first times 8.624 times 10 to the negative second. Now, what do? Well, there's two main steps to start with. The first thing is I need to recognize that I have digits and then I have my powers of 10. So I'm going to start by multiplying my digits. 3.64 times 8.624. That is 3.64 times 8.624. And when I multiply these two numbers together, it gives me the value, using a calculator, of course, 31.39136. Okay, awesome. So far, so good. Now I want to take my powers of 10 and I want to multiply those. So I have a 10 to the first and a 10 to the negative second. Let's multiply those and get 10 to the negative 1 times 10 to the negative 2. And when we have like bases, we add our exponents. So that gives us 10 to the negative 1 plus negative 2, which is just negative 3. So putting that all together, we have thus far the value 31.39136, or if we like, times 10 to the negative 3. Or if you like, 39,136 hundred thousandths. Yeah, I'm just going to say 31.39136 times 10 to the negative 3. The rest is just a mouthful. All right, so we have 31.39136 times 10 to the negative 3. But that answer doesn't quite match the answers that we have to choose from. Well, first of all, those answers over there are written in scientific notation, meaning that the decimal appears after the first digit in the number part. That doesn't occur in what we have. So we need to rewrite our answer, 31.39136 times 10 to the negative 3, into scientific notation. There's a couple ways to do that. I'm going to probably take the longer way because most students seem to understand this a little better, but I'm going to start by taking this number and rewriting it into decimal notation. 31.39136 times 10 to the negative 3. Well, that 10 to the negative 3 tells me that I can move my decimal place 3 places to the left to get my decimal number. That means I have 0.031399136. Let me check. I think I copied my digits wrong, but let me check that again. So I have 0.031399136. Nope, everything's good. So that's my decimal number. Now I'm going to take this decimal number and rewrite this in scientific notation. To change this number into scientific notation, I look and I put a new decimal right here after the 3. That means I'm going to have to move 2 places to the right. That means I have the number 3.139136. Check our digits. So that moves 2 places. So it's 3.139136 times 10. And now what's my exponent? Well, this number is a very small number. It's actually, what is that number? It's 3,139,136 hundred millionths. That's a really small number. So this exponent up here, whatever it is, has to be negative. That denotes really small numbers. Well, what is my exponent? I had to move 2 places to the right, and so that tells me that my exponent actually has to be negative 2. So the number I get is 3.139136 times 10 to the negative second power. This almost matches our answers over here. There's one more thing we need to do. This problem says we want to note that the number of significant digits in the answer should equal the least number of significant digits in the numbers being multiplied. Okay, that's another mouthful. What does that mean? So the number of significant digits in the answer, so that means the number in our answer should equal the least number in the number being multiplied. All right, in the numbers being multiplied. I have two numbers, 3.64 and 8.624. Of those two numbers, the one that has the least number of significant digits is the first guy, because the first guy here has 3 digits. This guy has 4 digits that are significant. So I have to take the smaller of those, which is 3 significant digits. My answer down here should have at most 3 significant digits. So let's change and convert it to have 3 significant digits. That's the last step. To get 3 significant digits in this problem, I want to look right here and focus, now I'm getting more tongue-tied, specifically on getting a number with 3 digits, 3.13, but notice 3 will have to get rounded up because of the 9 next to it. So if I want to go down and get a significant figure of 3 digits, I have 3.14 times 10 to the negative 2. That's my final answer, and I think that is a choice in our selection. 3.14 times 10 to the negative 2, this guy right here. So that's the correct answer. Written in scientific, okay, slow down, Tina. Going too fast here. So that's part A. Part B, now I want to take that answer and rewrite it into decimal notation. So let's take this guy and put him back into decimal notation. Remember, 2 digits to the left, which is 0.0314. That is now the answer written in significant notation. That is now the answer written in decimal notation. And that matches this answer right here, 0.0314, or if I like, 314 thousandths. All right, that was a long problem. I kind of went about it kind of a little convoluted, but I find that students seem to understand this way and this method. If you see a different way, do it the different way, but that's how I would go about doing it if I was suggesting it to you. Good luck with your study, and if you have any questions, let me know.